Hey Algebra 2 students, welcome back. Today we're looking at 3-24, match rational functions. This is going to be a real quick one. So the steps we're going to take in order to match a rational function's equation to its graph is 1, we're going to find asymptotes like we did before. 2, we're going to check points in each sector. And 3, we're going to find the best match. So let's go ahead and do this. We're going to go look at an example in Alex. So let me pull it up here. So we have two equations, 2x minus 2 over x squared minus x minus 6. 2x minus 2 over x squared minus x minus 6 is our first one. And then 6 over x squared plus x minus 12. 6 over x squared plus x minus 12. Alright, so the first thing we want to do for each of these is find the asymptote. So let's go ahead and change colors here. So remember, the vertical asymptotes occur where the denominator is going to be equal to 0. So let's go ahead and figure this one out. We're going to factor x squared minus x plus x squared minus x minus 6. So we're looking for multiplies to get negative 6, adds to get negative 1. We'll put our x's in there. So the numbers that are going to give us negative 6 when we multiply and negative 1 when we add are going to be negative 3 and positive 2. Likewise, for the second one, we're looking at what multiplies to get negative 12 and adds to get positive 1. That's going to be positive 4 and negative 3. Now, remember, that's what we're trying to find when these are equal to 0, right? So the zero product property applies. We have two things that multiply to get 0. If that's the case, the only way we can multiply two things to get 0 is if one of the numbers is 0. So let's go ahead and figure this out. X minus 3. What minus 3 is 0? 3. The next one, x plus 2, that would be negative 2 because negative 2 plus 2 is equal to 0. Okay, so let's list them over here. And then on this side, we got negative 4 and positive 3. Okay, those are our vertical asymptotes. Let's now find our horizontal asymptotes. So like we did before, the horizontal asymptotes we're looking at are degree of the top and degree of the bottom. So if the degree of the top is less than the degree of the bottom, then we have a horizontal asymptote at y equals 0. Right, so same thing here. The degree of the top is 0, the degree of the bottom is 2. The top is less than the bottom, so we have another one where our horizontal asymptote is 0. Now let's just go ahead and check here which ones have vertical asymptote at 3, negative 2, and horizontal asymptote at 0. Alright, so 3, negative 2, graph A checks out, horizontal asymptote 0, good. Part B is not at 3. Oh, it is at 3 and negative 2. Horizontal asymptote at 0. Graph C is at 3 and 2, but the horizontal asymptote is at negative 3. Notice for C, we have that dotted line going at negative 3 through the y-axis. Okay, so A and B are an option. Let's look at D. Negative 2 and 3 vertical asymptotes. Oh, sorry, look, graph A is not one. Sorry, graph A, I thought that was at negative 2, but it was at negative 4 for our vertical asymptotes. So far B and D are options. Okay, so between B and D, let's see if we can figure out what's going on here. So notice that for graph B, if we're starting all the way on the left, it goes from negative all the way to the asymptote, then it goes decreasing in the middle, and then on the right side is positive. Whereas for D, we start on the left hand side positive, and then between the asymptotes it's increasing, and then outside the asymptotes on the right hand side it's all negative. So if we can just find one of those points, we could determine which one is the correct answer between B and D. So I don't know, let's look at the left hand side. So let's pick a number that's less than -2 because we want something to the left of the asymptote, and if it's positive then we know it's graph D. If it's negative then we know it's graph B. So let's test a point. So I don't know, left of -2, -3. Let's do -3. So let's just take our -3 and plug it into our equation. Make sure your signs are correct. Okay, on top we have 2 times -3 is -6 minus 2, which is -8. Over the bottom is -3 squared is 9. Minus negative is plus 3, which is 12. And then 12 minus 6 is 6. So this is going to be -8/6, and we can reduce it. But the important thing to note here is the sign. So let's go back and look at where the left-hand side of our graph is negative. So between B and D, that would be graph B, right? Because the left-hand side of the first asymptote is going to be negative. So we can choose graph B. Okay, and then let's go figure out the second one. So the second one, we're looking at where our vertical asymptotes are -4 and 3, and our horizontal asymptote is at 0. So let's go back here. Graph A, vertical asymptotes -4 and 3, horizontal asymptote at 0. Also, graph E, we have vertical asymptotes at -4 and 3 and horizontal asymptote at 0. Graph F does not fit because while the vertical asymptotes are correct at -4 and 3, our horizontal asymptote is at -3, so that's out. So now we just have to determine between graph A and graph E which one is the correct one, and we can use the same thinking. But this time, let's look at the right hand side of our graph. So after the second asymptote towards the right, if you notice, graph A is negative while graph E is positive. So if we check a point there, we can determine which one is the correct graph. So let's pick a number to the left of that asymptote. So we can work with 4, right? Because 4 is greater than the left hand of the right hand asymptote. So we're going to plug in 4 to our equation. So I'm going to do 6 over 4 squared plus 4 minus 12. So we got 6 over 4 squared is 16, plus 4 is 20, minus 12 is 8. Again, we can reduce it, but the important thing is notice the sign. So the sign is positive here. So we go back to our graphs. And between A and E, the one that we have positive on the right side, because we checked a point on the right side, would be graph E. So let's go and put graph E. Check. And then we're good. Okay, so just another recap. Excuse me. First we found our asymptotes, right? Horizontal and verticals. We eliminated the graphs that were not, that did not follow these asymptotes. So that narrowed it down to 2 for both cases. Once we did that, we had to determine which one was the correct one. So we pick a point, usually to the left or to the right of our asymptotes, on the outsides of our asymptotes, and we determined which graph we selected by plugging our number that's greater than or less than, depending on which asymptotes you're looking at. into our equation, and then we determined if it was positive or negative, and then we chose the appropriate graph where the graph was above the x-axis or below the x-axis. All right, good job today.